All right, let's take just a bit closer look at the periodic table and look at a few things. Okay, first, there's going to be columns and rows in the periodic table. Okay, the rows are known as periods. So the rows in a periodic table are called periods, and the columns, each of the columns is called a group or a family. Okay, so groups are the vertical columns, periods are the horizontal rows. And there are going to be a bunch of different ways we're going to categorize and sort the elements. One way is through main group elements, where main group elements are the first two columns and the last 6 columns. Those are main group. The ones between the main group here are called transition elements, sometimes called transition metals, because they're all metals. And the piece in the bottom, they're called the inner transition elements or the inner transition metals. Okay, that's one way we break down the periodic table: main group, transition, and inner transition. Another way to do that is a lot of the columns are named. So a lot of the groups or families are named. For example, this first column, not including hydrogen, but lithium, sodium, potassium, rubidium, cesium, and francium, are known as alkali metals. And the alkali metals are all very reactive. By very reactive, I mean react with air. So they have to be stored in things that don't allow water or air to get to them. Sodium, potassium, lithium, if you put them in water, they explode and they burn violently. So this first column, they're all very reactive. And we don't find those metals in the Earth's crust pure. Like we can find gold in the Earth's crust or silver in the Earth's crust pure. But sodium, potassium, rubidium, cesium, they're not found pure. They're always reacted with something. The second column are called the alkaline earth metals: beryllium, magnesium, calcium, strontium, barium. Again, they're reactive. They're quite reactive, but they're not as reactive as the alkali metals. So if we go over to the right side, the last column are known as the noble gases. Those are elements that are not very reactive at all. For example, helium doesn't react with anything. Neon doesn't react with anything. Xenon will react a little bit, and krypton will react a little bit because they're bigger atoms. But for the most part, the noble gases are quite unreactive. The column next to those are called the halogens. And the halogens are a lot like the alkali metals, except they're for the non-metals. Okay, we'll get to here in a second. So the halogens are the really reactive non-metals. And then, honestly, the oxygen, nitrogen, carbon families or groups are also named, but we're not going to worry about that. Typically, elements in the same column have very similar properties. So, for example, the first column, they're all metals, they're all very reactive, they have similar melting points and things like that. So, elements in a column are pretty similar, and then as we go across the table in a row, across a period, the properties are going to change in a pretty systematic way. Okay? If we go a little bit further, we can categorize the elements as metals, nonmetals, or metalloids. In the upper right-hand corner are the nonmetals. Those elements, they're not, they don't conduct electricity, they don't conduct heat. They all have kind of unique properties. So there's a range at room temperature of solids, liquids, and gases. Carbon at room temperature is a solid. A lot of them are gases like helium, neon, argon, krypton, xenon, chlorine, fluorine, oxygen, nitrogen. Those are all gases at room temperature. Sulfur is a yellow solid. Chlorine's kind of yellowish green gas. Bromine is kind of a purplish brownish liquid. Iodine is a brownish solid, purplish brownish solid. So they're all kind of unique properties. Hydrogen is also considered a nonmetal. The blue ones here are all metals. So you can see most of the elements are actually metals. Metals are interesting because they all look a lot alike. Most of them are silver and shiny. Some are a little bit darker silver, some are lighter silver, but most of them are silver. Some version of silver. Gold obviously is gold colored, but it's still shiny. Copper has that orangish copper rust tint to it. But for the most part, most of them are silver. The other thing about metals is that they conduct heat and electricity. They are very flexible. You can kind of pound them and make flat metal surfaces, or you can pull them into wires. The only one that you really can't do that to is mercury, because mercury at room temperature is a liquid. And then the last few elements here are these pink ones that kind of separate the metals from the nonmetals. And those are the ones that kind of are in between the two properties of the two. And those are called metalloids. Sometimes they're called semi-metals. Just depends on what book you're reading. Your book uses metalloid. Okay, so you got the non-metals in the upper right corner. You have the metals everywhere else, which is kind of the left side. And then that diagonal that exists between the two, those are called the metalloids. Okay, and if we look at elements that are really important for health or for life, the blue ones are just fundamental pieces of life. They're the building blocks. Hydrogen, carbon, nitrogen, oxygen, phosphorus, which we talked about earlier, and then we threw in sulfur here also. Okay, so those are going to be the things that are the building blocks, right? So that make water, hydrogen and oxygen, that build proteins or nucleic acids or lip fats or sugars, amino acids. All those things are made of those elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. Okay. Macronutrients, so elements that you need more than 100 milligrams a day, are highlighted in orange. And that's going to be your sodium, your potassium, your calcium, your magnesium. And then chlorine, sulfur, and phosphorus are also considered macronutrients. And then micronutrients are the other elements you need, but in less quantity. So less than 100 milligrams a day. And that's going to be iron, manganese, cobalt, copper, zinc, selenium, iodine for thyroid, fluorine, for teeth, silicon, vanadium, chromium, molybdenum. So all of those elements are critical to the function of your body. You just don't need a lot of them. And there's a lot of reasons for that. One of those is that they don't leave your body very easily. Like iron, once it's in your body, doesn't leave much as waste unless you cut yourself or something like that. Then you might lose a little bit because it's in hemoglobin. But for the most part, those elements are in your body and remain in your body. So you don't need to replenish them or anything like that. Okay, that's kind of our deeper introduction to the periodic table.